In this lesson, we're going to learn more about the slopes of parallel and perpendicular lines. And to do that, we're going to work through a few questions just to make sure the concepts are really clear. The first question says that line 1 has a slope of negative 5/14 and line 2 is parallel to line 1 and contains the points 9, -1 and x, 4. So we don't know what x is. And the question is, what is the value of x? So let's begin by writing out the formula for slope. That's going to be important here. We're going to have slope equals the change in y, so y2 minus y1, over the change in x's, x2 minus x1. And let's go ahead and plug in the values we have. We have 4 minus -1 for the top, so 4 minus a -1, and we have x minus 9 for the bottom, x minus 9. And let's go ahead and simplify that numerator. 4 minus a -1 is 5, and the denominator is as simple as it can get right now, so x minus 9 will stay in the denominator. Now we have an expression and we have a variable, one variable. We need an equation in order to solve for that x. And all we've done so far is simplify an expression. We actually need another expression that's equal to 5 over x minus 9 to be able to solve for x. Fortunately, we know that parallel lines have the same slope, and we were given the slope of line 1. So we're going to use that. We know that our slope equals negative 5/14, so we can set this expression equal to negative 5/14. And now we have an equation with one variable, so we can solve for x. So I'm going to rewrite that down here, and that's going to be 5 over x minus 9 equals negative 5/14. Now we can cross multiply and say 5 times 14 and negative 5 times x minus 9, or we could notice that if we move this negative sign to the denominator, which is allowed, and instead of writing negative 5/14, write 5 over negative 14, which is the same value, then we have the same numerators, 5 and 5, and we can just simply take these denominators and set them equal to each other. So if you'd like to take that shortcut, I think that's going to work out nicely. That's going to give you x minus 9 equals negative 14, and when we add 9 to both sides, x is going to equal negative 5. So the answer to this question, what is the x coordinate that should go right here in this point? It's going to be x equals negative 5. Now let's take a look at another question. It's a lot like this one. This one says that line 1 has a slope of 3/4 and line 2 is, instead of parallel, it's perpendicular to line 1, and it contains the points 6y and 312. What is the value of y? Okay, let's use the same procedure as we did in the last question. So we'll have m equals y2 minus y1 over x2 minus x1, and we'll just plug in the values that we have. So we've got 12 minus y for our numerator and 3 minus 6 for our denominator. And we'll go ahead and simplify this denominator. So in the numerator we have 12 minus y, and in the denominator we have a negative 3. That gives us the first half of an equation that we can use to solve for y. Now we need the second half, and fortunately we know what the slope of line 1 is, and we also know that line 2 is perpendicular to line 1. So we're going to use that. We know that perpendicular lines have a negative reciprocal slope, so that means they have opposite signs and we need to flip the fraction, or it's a reciprocal. So we know that this equation should be 12 minus y over negative 3 equals negative 4/3. Now we have enough information to solve for y. Now we could use that shortcut I showed you in the last problem, where we could change this negative 4/3 to a positive 4 over negative 3. It means the exact same thing, and what that would do is give us the same denominators, and then we could set the numerators equal to each other and solve for y. That's one way to do these problems, and it's a quick way. But just in case that's confusing and maybe you need another way to do this problem, I'm going to go ahead and show you the steps of cross multiplying. First we would multiply diagonally like this. So 3 times 12 minus y equals, and negative 4 times negative 3 would give us a positive 12. And at this point we could distribute, or we could go ahead and divide by the 3. I think we'll do that since it comes out so nicely on the right hand side. 12 divided by 3 is 4, and that gives us 12 minus y, and we don't need the parentheses anymore here. I'm going to go ahead and bring this up here to finish solving. So we have 12 minus y equals 4, and we could add y to both sides and subtract 4 from both sides. So that'll give 12 take away 4 equals a positive y, and 12 minus 4 gives us 8. So in this case, the value for y is 8. Now let's take a look at a problem where we're finding the equation instead of just a missing coordinate. Find the equation of a line that passes through the point 9, negative 7, and is perpendicular to the line y equals 1/3 x plus 5. Now it's very important to notice that the equation we're finding is not the y equals 1/3 x plus 5. It's a line perpendicular to that line. So the only thing we're going to get from this equation is the slope that we need. And we know that perpendicular lines have negative reciprocal slopes. The slope of this line is 1/3. So the slope of the line we're looking for is going to be negative 3. Negative 3 over 1, but we don't need that 1. Now it wouldn't be enough just to know the slope, but it is enough to know the slope and one point on the line, and that's all we need. So we know that the slope of the line we're looking for is negative 3, and that a point on this line is 9, negative 7. There are several ways to come up with this equation. I personally like the slope-intercept form of an equation. So let's start with y equals mx plus b, just the general form of any line in slope-intercept form. And let's plug in what we have. We have that when x equals 9, y equals negative 7. So I'm going to plug negative 7 in for y. And for x we're going to put a 9. We don't know b yet, but we also have the slope. So we've got a negative 3 that goes in place of the slope. We have one point which gives us an x and a y, and we have the slope. So the only thing that's missing is the b, which gives us one equation with one variable, so we can solve for b. First, let's simplify the right-hand side. That'll give us negative 7 equals negative 3 times 9 is negative 27 plus b. And we'll add 27 to both sides, which gives a positive 20 equals b. Now we know what the y-intercept is, and we have enough information to complete the equation of the line we're looking for. The equation is going to be y equals our slope of negative 3 times x, and then we're going to add the b at the end, so plus 20. The equation of a line that passes through 9, negative 7, and is perpendicular to the line y equals 1/3 x plus 5 is y equals negative 3x plus 20. Now you know a bit more about finding slopes of parallel and perpendicular lines. See you next time.